Hello everyone, my name is Sriharcha Balsu and I'm a graduate student at University of Maryland, Baltimore County. This project is part of my capstone from the final semester. So the main objective of the project is to predict the outcome of the service request based on the agency and the method received. So all about 311. So i- it's like 911 but for non-emergencies. It is how we can report issues within a city such as tree down, potholes on road, trash problems. Also, some cities rely on co- communities to help homeless that might need assistance. 311 is how citizens in a community can help bring awareness in non-emergency issues and make sure authorities are aware that they exist. The open format allows municipalities to store and provide access to 311 data in a way that uses the same vocabulary, allowing it to easily share between providers and aggregated across many locations. The main objective of this project is to predict the outcome of service request received based on the agency type and the method it was received. The data set I used is obtained from Open Baltimore website. This website contains all of the open data related to the city of Baltimore MD. 311 connects Baltimore citizens, businesses, visitors with a vast array of city services, programs, and information. Customers can request a service either by live agent phone call, that is, calling the customer service representatives to inform about the issue they're facing, or through the self-service web, that is through the mobile application or to the web portal. So the key attributes of the dataset are service type, that is a type of service requested. The second one is method received, that is how the service is received either by API, phone, or through web. The third one is service status, whether the service, I mean the present status of the service agency to which agency is nothing but to which the service belongs, or the agency which is responsible to clear the service outcome. It stands for outcome of the service request. When coming to data cleaning, some unwanted columns such as longitude, latitude, and geolocation are dropped as they have nothing to do with modeling at all. Also, the rows which contains null values are removed as they do not make any difference in further steps such as ED and model building. The column pol- police page police post sorry the column police post contains most of its values as null values, and so the column is dropped. Later, ETA, that is exploratory data analysis, is performed on the final data, followed by model building and model evaluation. When coming to some of the insights of ETA, the first one is the pie chart that represents the stats of method received. You can see 48.3% of the service requests are received by phone call to the customer service agents. The second highest is 23.8%, that is through API, and the third one is 13% through system and all. We can easily say that most of the service requests are received by phone when come and by phone, followed by API and system and internal when compared to others. Out of the 19 when coming to the agency types, this bar graph represents the agency types. The number of service requests that belong to each and agencies. These are the agencies, and these are number of service requests they receive. Out of the 19 agency types, only the first 10 have a minimum value. Like we can use these. We can only use these for modeling and not the rest of them, as they do not have much value when compared to this. Uh, this is the value counts of every agency type. So the solid waste contains 35K role values and transport contains 11K, and housing and all. Sorry, 354K and 118K and 79K and all. So we can see some agencies such as Liquor Board, Public Works, BCIT, Mayor's Office, Police Department, General Services. This all does not have a pretty good value when compared to others. So we can get better modeling results if we drop the agencies with less values. When coming to the service type, there are a lot. There are like three not kinds of service types, out of which only some have a reasonable value. I only have like 50 or 16 here, but they are way more better. I cannot even fit them in the graph right here. I mean, the main one is rat about proactive. That is, many customers are facing a issue with rats in their households or businesses. These are the value counts of all the requests. So these are the top 20. The highest comes in as rat robot proactive, and the second highest is bulk schedule that comes under solid waste. The third one is information request that comes under tourist inquiry and all, and sanitation property, parking complaint, water leak, vacant building. The interesting thing is vehicle removal. That is, people call 311 to inform that there is an unattended vehicle in their parking lot and it must be removed and all. So when coming to the outcomes, there are many outcomes, out of which only first five of them are have a reasonable value. First one is work completed, and the second one is service request closed by agency specific management, and the third one is work could not be completed, and the fourth one is service request assessed and no cost determined by the agency, and the fourth one is work referred to another agency. And as we can see, the rest of them do not have a good value. These are the value counts of all the service requests we got. When coming to the service status, that is the status of the service request obtained, many of them are closed. I mean, either it may be at addressed or it may be moved or something, but many of them are closed, which means that service request has been addressed and closed by specific agency. When coming to choosing the attributes for model building, I choose method, received, agency, and outcome. Model building. Initially, label encoding is performed to convert the columns outcome, uh, outcome, agency, and method received. It is because we cannot predict categorical variables. So this is why we convert these categorical variables into numeric variables, and then we predict them using various modeling techniques. The data is then split into training and testing sets in the ratio of 67:33 respectively, and a pipeline is built using the pipeline object from a scikit learner pipeline. This is the working model of a pipeline, exactly meaning a machine learning pipeline. So machine learning pipeline includes raw data, input features and all, and the machine learning model and parameters and prediction outputs. It comes under model deployment. These are some of the code snippets. The first one said the input variables, and this is the output variable, and this is the implementation of pipeline, which contains two regression algorithms. First one is decision tree regressor and the random forest regressor. A pipeline is created which contains a dictionary in which the first key value is decision tree and the other key value is random forest. So later, the model is built, and using accuracy, we go for model evaluation. The decision tree accuracy came out to be 39%, and random forest accuracy came out to be 74%, which is far more better than the decision tree accuracy. Also, using grid search cross validation, the validation of the model is performed, and random forest came up to be the best than the decision tree test accuracy, given the parameters max depth of the tree and min samples leaf and max leaf nodes. uh, Grid search is performed in order to search for the best parameters using grid search cross validation from scikit-learn model selection package. And the results from grid search cross validation are analyzed. The decision tree regression accuracy score is 68%, and the accuracy score of random forest regression is found to be 73%. That is it, guys. Please leave a comment if you have any doubts or anything. Thank you. Have a good one.